Alright, second part of our notes. I'm moving on to a new sheet, and this topic is going to be about convection. Okay. So remember, we talked about convection on the geology notes as well. We talked about how in magma, the hotter bits of magma usually rise to the top, and as it cools, it lowers, and it forms those circles of magma to where they have constant movement. The hotter magma is moving up, cooler magma is moving down. So convection can occur in different substances. So convection occurs in different substances such as, okay, so we talked about it in magma, but it can also occur in water and air. So today we're going to be talking about some air convection. So talking about this, the process of convection in the atmosphere brings warm, damp air up, and then cool, dry air falls. So the process of convection in the atmosphere and we're going to draw an arrow this way because now we are going to draw it. Okay. So we said convection, warm, moist air rises, and this is a lot of times after it rains. You know how it kind of gets hot and muggy, so that is when the hot air rises. So rains, okay, and then we have an arrow that's going to go this way because you know it's eventually going to move, and we're going to have a big cloud up here because that warm moist air is going up, forming into the clouds. And then over here is when our cool, dry air falls. Okay, and then near the ground, that air is moving over. Okay, so under this box, we know warm, moist air rises. It cools in the upper atmosphere. Drops moisture, so when it rains, it drops that moisture. And diverges. Then the cool, dry air falls on a different latitude. So what that's meaning is when this warm air rises, it doesn't just fall right back next to it. So when it rises, it drops the moisture and it diverges and it moves over, and it's going to come down in a different area. It's not going to rise and just come right back down. It rises, moves over to a different latitude, and then falls. Okay? So many deserts are found around 30 degrees north and south So 30 degrees north and south latitudes. And it's caused from this process. Because when we think about it, sun hits directly onto the equator, or most direct onto the equator. So of course that's going to have the hottest air. So right at the equator is where that hot air is going to start rising. And then remember, so picture equator's here, so hot air is rising. Remember, it moves over and then it drops. So where it's dropping, the cool dry air typically falls at about 30 degrees. And that's why we find a lot of deserts in those areas, because that's where the cool dry air happens to fall. Okay, so now we're going to talk about the convection cells on Earth. Okay, so now we have to draw an Earth. Okay, so I'm going to draw my line for the equator. Remember, 23.5 above is our Tropic of Cancer. 23.5 below is our Tropic of Capricorn. Okay. On this one, you don't have to draw your countries. I mean, if you really want to, you could. But right here at the equator is typically going to be more damp. Remember, these are our tropical regions. We have a lot of direct sunlight. And remember, we have warm, moist air. So this is going to be wet at 0 degrees. Okay. And this is where we started talking about when the sun hits directly at the equator, this is where that hot air is going to be rising. So right here, hot air is going to rise. It's going to move over towards our almost 30 degrees. So we're going to go a little past this. This is where the cool air is dropping. Remember, typically where we have our deserts. And then it's going to go back over. So make sure you draw arrows on this showing that your hot air here is rising, cool air is dropping and moving over. So if you want to make it a little better and easier to see, I would have this as red here and turning red. Then we're turning to blue as it's cooling and dropping. And then we're turning back to red. Okay? And so this area right here, from the equator to about 30 degrees, is called a Hadley cell. Okay? So we had wet, 0 degrees, hot, damp air coming up, and then cool, dry air coming down here. So this is going to be our dry 30 degrees south. Okay? And then this process is going to somewhat happen again. But remember when we talked about magma, how we had hot magma rising, cool magma falling, but the spaces right next to it went opposite directions. Remember, we had cool magma falling in this direction and hot magma coming up in this direction. So remember, they alternate directions next to each other. So the same thing happens during convection with air. So right here, let me get my pencil. In our next cell, same thing is happening, but we're going in the opposite direction. So here is where our cool air is falling, and then it's coming over and getting warmer and rising and moving over. So cool air falling, warm air rising. Remember, it's going in opposite direction just like it did when we were talking about magma. And then down here, we call this one a Ferrel cell. Okay, and over here, if we have red, that means the air is warm and moist. So this is going to be a wet area. Okay, and then it's gonna happen one more time down here towards our pole. And remember, we're going opposite directions. So this time, hot air is rising right here, cooling off, cool air falling to the earth, and warming back up from the sunlight. Okay, so we've got warm, turning cool, dropping cool air, moving over. Okay, and this one we call a polar cell. Of course, it's at the pole, so easy to remember. It's a polar cell. And down here is going to be our dry 90 degrees south, because we are at our south pole. Cool air dropping. Cool air is typically dry, so it is a dry area. Now the same thing happens going north from the equator. So it's going to be the same exact thing happening. Sunlight hitting this equator, heating up the air, so we have that hot air rising, going over, cool air dropping, and coming back around. So we have hot air rising, cool air dropping, and coming around. Okay, and just like over here, if our cell is right near the equator going to one of our tropics, it is still called a Hadley cell. Okay, and if cool, dry air is dropping right here, this is going to be dry at 30 degrees north. Okay, and then same thing happening as over here. We have our cool air coming down, going over to warmer, hot air rising, coming down. Okay, and again, just like over here, if it is the tropics going towards the pole, it is called a Ferrel cell. Okay, and if we have hot air rising, that means it is going to be wet at 60 degrees north. And then remember, we have our one more cell going towards the poles. So going in the same direction as right here, we have hot air rising, moving over, cool air dropping to complete our cells. Okay, and same thing, this is by the pole, so we call this a polar cell. And if we have cool air dropping, that means it's going to be dry at 90 degrees north. Okay, and I can erase this here from magma. I'll move this where you can pause if you need to look for a second before I move on. Okay, so the reason we're talking about convection with this air and why hot air is rising, cool air is dropping, and why and where this is all happening is because this affects which direction our winds typically blow. So at the equator, between the equator and the Tropic of Cancer, wind typically goes towards the left and down. And I'm about to explain why. But at the Tropic of Capricorn to the equator, it's going up and to the left. And this is what our direction of wind is. So that's what these arrows are representing. Above the Tropic of Cancer, going towards our pole, the air is doing this. It's going up and towards the right. And up here, it's going towards the right. Below our Tropic of Capricorn, it's going down and to the right. And right here, it's going to the right. Okay? So the combination of convection, and the next thing that we're talking about is why these winds go typically in the direction that they do. So the next thing that we're going to talk about is called the Coriolis effect. And the Coriolis effect means that the spin of the Earth on its axis diverts substances to the right in the northern hemisphere and to the left in the southern hemisphere. Okay, now I know when you're looking at this Earth, the northern hemisphere, we said it diverts substances to the right. But when you're looking at this, the arrows are pointing left. And I know that doesn't make sense right now, but we are going to do a lab as soon as they let us all come back to school that will hopefully help make this make sense of why we're saying it diverts substances to the right in the northern hemisphere, but we're drawing the arrows to the left. I promise I'm going to try to make that make more sense, but the easiest way to do that is have you do it yourself and see in the lab. So we will do that as soon as we can come back to school. So the Coriolis effect, hopefully that didn't cut me off. Okay. So to put it in simple words, the Coriolis effect means that on our Earth, okay, our equator is right here. Okay? You would think that if a wind started blowing from the equator north, it would just go straight up. But the Coriolis effect tells us that it cannot go straight up. It has to either turn right or turn left. And the reason being is that our Earth is round. So a wind going straight up eventually has to curve around the Earth. And since the Earth is turning at the same time that the wind is moving and our Earth is round, the winds are going to curve in a direction. And I know that's hard to imagine right now, and I promise when we do the lab, when we can finally come back together, it will make more sense. But this just strictly tells us that because the Earth is round, because it's spinning, that winds are not going to go just in a straight direction. They're going to end up curving to the right in the northern hemisphere and to the left in the southern hemisphere. And again, my arrows may not make much sense right now, but I promise they will later. So convection cells, what we talked about above, plus the Coriolis effect is what creates our winds. So, I promise, I know this is a little confusing and hard to grasp right now, but I know when we do the lab, it will make a lot more sense. So, a combination of how the warm air rises and cool air falls, plus our Earth being round, tells us the directions that wind will typically blow in certain areas of the Earth. And that's kind of the main gist that I'm wanting you to get from this, and I'll make it make more sense later. So let me know if you have any questions, but that's the second page.